So in the previous problem, the triangle one, the tabulation method, we aren't able to solve that, nah. So it is easy. It is easy. We haven't thought about that. So what was happening is that we are recursively calling from, let's say, 0 0, obviously, and we are moving to the from top to down like this thing. Yeah. So like 0 0 to like n minus 1 and n minus 1 down, or diagonal. Yeah. So these things we were doing in a recursion, top down approach. But in the let's say what tabulation approach, what I have to do is to, it is always, since we know it is top down, it is bottom up. So bottom up, it's top down, it is bottom up. See the previous solving stuffs, we will see that if we are doing like top down approach, like from n minus 1 minus 1, it is from zeros to like that bottom up. We reach from top to down, 0 0, and n minus 1 minus 1 will give us the, like the, sorry, 0 0 up to that. Yeah, like from bottom to up we go. Yeah, in the recursion, let's say, like, sorry, bottom top down approach only, but we are have from n minus 1 minus 1 to 0 0 and come to that position. But here, in the tabulation method, we do the reverse thing. From 0 0 to, we go from this to this, top down, bottom up. So pretty simple. That is the difference between these two things. So here, tabulation you have to do like bottom up. So it will coming from this to this, opposite to the recursion method. So obviously we have to come from this to this. Now you have to write the base case. What was the base case there? Is that when we reach this position, to add the stuff that is here. But in this approach, what the error we were doing is that the 0 0, then we reach here and we just add the stuff. It's not happening. Okay, what do you have to do? The base case, let's say, base case, that is initialization, we can say, in this approach. But what the initialization would be? That the initialization would be like the base case. Base case is from like when you reach this position. Just add that position. So for int j 0, j less than, okay, j less than obviously n minus 1, n plus plus number of rows, and if if what, no need, just add stuff in the dp of m minus 1 j is equal to the triangle of minus 1 j, last rows, like each stuff is the base case or the initialization thing. We have initialized the last row. Now move to the up. The previous problems, when we are doing recursion from top down approach, we are from n minus 1 to 0. So it will be like getting my stuff, what I'm telling should understand. So it will be like n minus 1. It will be like greater or equals to 0, and it would be minus minus. Always think reversely. Minus minus. And see, if you see the, what do you call, the this thing, it will be like 0 for 0th row, it would be 0, I think. 0 columns, 0 1, 0 1 2, from 2 to 0, I think. And here you will see 0 1 2 3. That's how the triangle is made. So from end, if you see like 3 0 1 2 3, it will be 3 to 0 from I to 0. Stuff is clear or not? Should be clear. That okay. This thing is not required obviously, and we like dia and dg. Let's say d for down. Yeah, this is okay. And minimum of d and dg. Okay, so the answer is where we are finding. If you see minus one in the previous problems we have done. Okay, yeah, the answer was in n minus 1, and here answer will be like 0, 0. Always think, if you think of that opposite to that thing, where the answer is found. Expected something. Um, what? Okay, some other. Um, hmm. Okay, so it will be like minus 2 because n minus 1 is covered already. Initialization. Here, expected member name this after declaration specify. What? Wow. Yeah, so you see the this is a very nice problem. It's make me think of very too much. The error was, I think, this thing, and we just have to this thing. Why? See, all these things are okay. There is no problem with this, but the error was that thing. What? See, we'll see the last row. There is M. There is only okay. M minus 1. So is 0. If you see, there is only 1 0, so it is not. So if you see this thing, it has same number of columns and same number of. So just need that thing. Okay, make this thing m minus 1 0 0. So Okay, hopefully you understood. 0 to n, obviously, cause it has 0 from like initialization, na? 0, 1, 2, 3, like this. Okay, so that is the stuff. And minus 2, why did we have make m minus 2? Because last m minus 1 is covered, initialization is done, so m minus 2 from m minus 2 I've done, and obviously from that also this thing is done, this thing is done, and at last the answer would be at 0, 0. So if you think of the recursion now, if you can think of the recursion, just opposite of that would be our answer. Where the answer is found? Obviously at the position 0, 0. Okay, so that's the stuff. Now let us solve this problem also. Minimum falling path sum. Okay, this is a nice problem. It's also a nice problem. So given an n-cross-n array of integer matrix, return minimum sum of the any falling path through matrix. A falling path starts at any element in a first row and chooses the element in the next row that is either directly or diagonally left or right. Okay, so you can move to the down, diagonally left, diagonally right. Yeah. So, and you have to get the maximum sum. And here you can take either of these positions. So here no fixed starting at no fixed ending. Reach like minus one. Let's say we can say 0 to m minus 1. Yeah, and get the maximum or minimum. Uh, Falling path starts one first row. Choose the element in the next row is either directly below or diagonal. Specifically, the next element will be yeah. So row plus one, that means this column minus one, that means I think this and this and this. Yeah. So okay. So and you have to get the minimum sum of the falling path through matrix. In sum should be minimum. Okay. Yeah, so think, how are we gonna solve this problem? There is no fixed path. So you can start from any positions and to just initialize. Let's say we are starting from the end, minus one, minus one. Then it will be like end from it. Okay, so if you're starting from the end, think of the end, then we just tabulate it to the, there's a 0 to 0. Okay, so as obviously starting is to the starting point. So in the tabulation you have to do like from the bottom up, so it will be like from I would be 0 and yeah. Okay. Oh, stuff is so we have something like this. Yeah, and we are here. No, let's say we are here. We can move up, we can move this position, we can move this position with the maximum. Okay, so up, we can reach here. Here can this can be let's say j less than 0, not valid. And here see one thing, so it will be like that, 0 up is not problem, but these two thing is problematic. So I think column only. J is less than 0 and J is greater than 0. Okay. And if you see, um, this is the stuff which is not, which is error. So at first we need to initialize now. Initialization base case. Base case is what? Reach the destination. This should be the base case, I think. Yeah. This will be a base case. Okay, so okay, I will write this base case. Base case is done. On the recursion, you do like initialization, then you move to the like tab, like we try to solve for the other stuffs. Okay, and it would start from the I think one and let's make it a matrix. I will disagree only. Oh, okay. Let's write the code, bro. I'm not. I'm coding from. Yeah. There is no triangle, so no need to think of that. Triangle makes things different. Triangle question is nice, I think. So I have to start it. Let's start it. Okay. Because this question made me like nice question. I can think that. Int T will be M and N and this initialization obviously initialization for int make it I doesn't matter. So where to start? To start obviously yeah 0 I should be 0 I less than obviously n plus plus okay and what do? We just add t of I would be like 0 I think and that thing okay it would be like matrix of 0 and I so either of them is the base case reach that position and that's the base case. Now what to tabulate it for the other stuffs for int I one because it is done that stuff is done now here okay starting from 0 only obviously yeah so plus plus for wait a minute so for int j will start from 0 only uh yeah so okay so now what we're gonna do we starting tabulating it from the one base case is done now to understand what the stuffs we can do we can either go to the stuffs what we are doing is that we can move int Okay, well there is something. If J is it should be like less than zero, less than zero or something. Yeah, if if J is less greater than hmm and then J is less than, okay, we are moving like less than n minus 1, less than n, sir. Then only we just do this stuff that is int up only. Would we like add the stuff? Okay, add the stuff that is J plus T of up na I minus 1. Die left L R. Oh my god, bro. I minus I plus 1 over 2 minus 1 over 2 minus 1 I minus 1 J plus 1. Let's make before that int TL would be here. Yeah, and after that return not T of I and J would be oh. I was thinking of that. So, with minimum of a comma minimum of TL TR. I don't know it will work or not. Huh, but the answer would be found. Answer would be found obviously at the position. Oh, okay. What? Yeah, so the answer would be found obviously in the oh either of this position. Either of this position will have the maximum. So we can make something like, yeah, so we can make something like minimum or something like int, let's say mini, which I make it like it would be like, let's say T of 0 and would be 0 or something. Mm, where the answer is found, obviously. Oh, and sorry. not 0, not 0, not 0. It will be found in the n minus 1, m minus 1, and let's say all this two. So minus 1 is a 0, and for int I, let's say starting from 1, I less than n plus plus mini is equal to minimum of mini and t of swan I, and return that stuff. Return that stuff. So let's see. Bro, okay, there is some error. Um, there is error, there is error. Otherwise, mm, ah, almost solved it though. Mm. Okay, so the error is, if you can see that error is up to this node. Here is the error. And it is always true. Doesn't make sense. You have to individually do that. If, hmm, yeah, yeah. Okay, so if if j less than greater than 0, then only you can do this thing. Okay. And okay, yeah, less than, let's see. Yeah. So there was a call that has came. So it was okay. So now what we were doing? Hmm. Yeah, yeah. So if s a j is greater than 0, uh, yeah. Else if let's make it something like this. Else if j is less than 0, t will be 1e9, and bro, this much. If it is greater than n, and here will be 29. Bro, what, bro? Let's try this one thing so that we can make something like this. Int. Wait. Just first of all change this thing. Wait. Did I have something? Did I have that thing? Let's make it DPO. That's why I don't like coding. You may be asking why is coding is so hard or something. Because it is like it shows too much error. That is the stuff. Oh yeah, I understood. 189 na. See what the thing you are doing that error right. See, we're gonna do int dl then oh equal star mark else ternary operator we are using, but I think there also we have made some error. Um, did we write if or something? I don't think. Yeah, it might work. Okay, there will be like er r 3 plus 1 and it would be like less than I think less than n charge is okay 4% bro fast yeah let me see please work bro what ah my charge is not there put it in charge yeah so the error was very simple though so where yeah here now so you have to write for the j minus 1 then 0 can write that or let's say j plus 1 less than uh n you can write that less than n and greater equal to 0 we can do that so you can see that pretty simple these things should be inside the range. I was doing something error that I didn't know. So hopefully I've understood my uh like what I've taught you in this lecture. So like almost we have done the grid problems on DP. If you find more problems, solve that. Solve more and more problems. Try to try to first of all solve it in your notebook. Do stuffs on that and try to get how you're solving. Coding is not a very big deal. Like thinking how gonna solve the stuff is that very much important than that of like writing the codes. Doesn't like you can write code, but you have to understand each and every line you write. Otherwise, there may be some error, there may be some you can't solve it. Try to try to also remember some stuff remembering stuffs because it will see if I have solved these three problems let's say it made me easier to solve the next problem if I solve more on this type then my thought process improve I will see the error where the error is coming. I will be more ready to solve this type of problems. That is what I have told you. And fully like this video, like, share, and don't forget to subscribe my channel. Bye.